what we are on the threshold of, or actually already doing, is the next level of democratization, where the power of cloud computing combined with the power of personal manufacturing will enable even more ways in which technology can make a difference to your lives. So how will you work when you think about it? First of all, you will design everywhere. So you will take your smartphone, capture conditions, go to any location that you may be at, and start to sketch out your ideas. By the way, everything I'm going to show you now is not a fake prototype. These are products you can use today. Okay? Nothing I'm showing you is future vision, something that is going to happen in the next 4 years. So tools like the one I'm showing you, you can start to use to create conceptual ideas and start to use the power of the cloud to shape selection and facades at the conceptual stage so that the things that are being considered are mathematically accurate. And in fact, given the fact that connectivity is anywhere and everywhere, you can collaborate with your colleagues in real time so that they can see the changes you are making in real time, and you are able, no matter where you are, be able to work with your colleague and start to make and shape designs very early on in the process in a collaborative way. That's how you're going to work. The other thing that you might want to do is capture the way things actually look. Laser scanning, and I know we have partners outside that will demonstrate laser scanning technologies. They've become so good that right now what you're seeing on screen is not 1 million points, it's not 10 million points, it's not 100 million points, it's not 1 billion points. It's 10 billion points being manipulated in the form of the scan of a village in Germany. And you can see how clear and how accurate that information is. So you can do very, very good level captures of existing conditions or existing structures way before you start doing your design. You will design like that. You don't no longer need to create information from scratch. You can take the physical world, make it digital, and then with those means of manufacturing, make it physical again. Make those changes. You can certainly do design not just viewing on these mobile devices. You will be able to do actual editing. Again, this is already possible today, and it's not just 2D line work like dimensioning or lines or circles or arcs that you're able to do. You can do actual 3D design on tablets. So you will be able to model everywhere. And so the example I just showed you seemed like a simple piece of geometry, but how about something that is more complex? This is the front fascia of a car, which involves very high level of surface modeling. This is running in a browser on a computer, and so the person had to install no software, and the thing that has been generated, you can see all these nice push-pull operations, and it looks like magic, whatever. What you should really see here is that it's possible today with web browsers and tablet technologies to do very complex modeling. Today these devices we look at are increasingly becoming capable of doing these zebra stripes that you see come up are actually a way by which you can see that the surface that was generated is very continuous. It's called G0 continuity for all of you mathematicians in the room. You are able to do very high levels of complexity. You can model entire roads, for example, here. So one of the challenges in civil engineering has always been that the technology available for civil engineering was never good enough to handle very large size projects. Almost every infrastructure project is 10 miles, 100 miles long. And up until now, we were never able to give people a modeling environment that could handle projects of that size. This is an example of a road, and what you saw go by was not just the fact that there was a 10-mile stretch, but you saw that as the person was designing, the computer was automatically calculating vertical optimization, horizontal optimization, and then the drawings came out at the end sort of as a byproduct. We talk about building information modeling, and every time we talk about building information modeling, people think we're talking about buildings only. What you just saw is that same idea applied to the world of infrastructure. So building in this situation was not a noun, was a verb, applying the idea of BIM to infrastructure. But the real idea that all of this computing power brings is the ability to go beyond form. For the last 25, 30 years, what we've been providing and what you've been doing with technologies is trying to describe what things look like. But what computing power enables you to do today and what products enable you to do today is go beyond form to function. Which means you can predict the way something will behave, not just the way something might look or the way something should be built, but the way it will actually work. Certainly in the case of mechanical design, you can see structures and simulate what they will do before they're built. Likewise, in the building industry, you can predict energy footprints. You will be able to predict more and more with greater levels of accuracy how buildings will perform when they are built. So performance. So you can look at fluid dynamics, and here is an example of something that, just like grammar checking, where you turn on in Microsoft Word and say, hey, check my spelling, your engineers will be able, or are able today, to check their work pretty much as they're designing and get performance information. This example was, sort of wind flow over the front of a car. But that same idea of fluid dynamics can be applied to consumer products, where you can look at heat being removed from an enclosure, which is almost always the biggest challenge you have when you're in consumer electronics. So the black lines is the way air will move inside to take heat away from those red hot areas. But don't think that this is just about manufacturing. In the AC industry, when you make data centers today, Google, Facebook, everybody's building these huge data centers. In fact, governments and private companies, everybody's building data centers. What's the biggest challenge in designing a data center? It's taking out the heat. So the same idea of predicting or figuring out the performance of those structures through fluid dynamics is possible today. I talked about the means of manufacturing. So again, we're going beyond form and going beyond function and going beyond performance to starting to predict how things can be made. There's a famous example. This is what I think you already haven't seen it on YouTube. You should. This is a hotel in China that got assembled in 11 days. From the time they broke ground to the time the first guest arrived, it was 11 days. Okay? Now, the way they did that, of course, was through prefabrication. So all the components were made off-site, basically manufactured. So putting the hotel together was pretty much like in manufacturing, where you assemble a large ship, for example, right? You weld things together, and that's really all they did in those 11 days, was stack those components one on top of the other and bolt them together. All the other things, all the components were already ready to go. That's possible today. So when you look at things like building information modeling, and what that enables for you is it enables you to start doing processes like this, start to figure out how you might take a building, break it apart into its components, and then assemble them again. Which means you need to pay attention to process. You need to pay attention, and technology today enables you to predict how things will come together across disciplines. So this is an example of a product we have today that, again, only requires a web browser. It's not Navisworks. This is 360 Glue that really integrates information from various disciplines and provides visibility into issues that might happen during the process of construction. Lets you take information with you no matter where you are. So you can go on site with all this complex information and look at the structures and then start to compare sort of where you are, so as built with as designed. And in a second, what you're going to see is somebody standing in a particular spot, holding up the tablet, and then comparing what she sees in the building to what, and you can see the design is automatically adjusting to show you what that structure should look like, right? So information follows you where you go, and you can start to manage the construction process with real information, not with a geometric abstraction of it in the form of drawings. Things like PLM 360 can give you insight and control in terms of what's going on in terms of all of the workflows, change management, all of the bill of materials, and all of the work processes that you need around your project. Now, if you think that all the stuff that I'm talking about is about cloud and computing and futures, there's an element of that that is true. As I said, I do think that we are in the middle of this revolution of getting information and computing power into your hands no matter where you are, no matter what you're doing, be able to access information. But the key to succeeding with that is by doing things right today. So what we do with building information modeling and what you do with that around creating, I just really want to say this for one. People think BIM is about three-dimensional drawings, three-dimensional models. That's only one part of it. The idea is all about information. I mean, you look at the internet, the thing you value the most about searching is access to information. If you want to manage your projects better, you have to start by getting the information in the right place, in the right way. Certainly, three-dimensional modeling is a very much a part of it. Integrating information from all the disciplines, from structural engineering, from HVAC, from MEP, getting all of that information in one place is really key to getting insight into your project. But it's not just, again, about form. Remember what I said. It's about cost, it's about schedule, it's about all the information that you need to make the construction actually happen. BIM is much more than the way things look. It is all the information relating to the project. And we have the same concept in manufacturing, which is the idea of digital prototyping, where the model certainly is one way to look at the information, but it's really all the information around materials, cost, quantities, all of that is very much a part of the entire model, the entire information model, not just the geometry or the fact that you're using solids and surfaces to make, describe the way things look. So we are here as software providers to help you take advantage of those opportunities and tackle those big challenges. What we try to do, of course, is build software, give it to you through our partners, and enable you to use that technology, whether it be in the form of suites or in the form of what we are calling a cloud-based offering, Autodesk 360. What we're here to do is enable you to solve those big challenges. We see our role as people that democratize technology and help you imagine, design, and create a better world. Every day, my team is inspired by the work you all do. Those examples that went by early on, and it went by very quickly, of some projects that are happening here in the Nordics, whether that be a hospital, whether that be a road, whether that be a building, a new product that is being made for the global market, those are things that we are inspired by. So I want to thank you for the work you do for the planet. And I'm certainly looking forward to everything that we can learn from you and help shape the products that we are here to build and help you imagine, design, and create a better world. Thank you very much. I hope you have a great day. I'll turn things back over to you.